P of x in descending order and answer the following questions. Okay, first of all we need to write the polynomial in the descending order. And what is the meaning of descending? Starting from the highest degree and moving towards the lowest one. Okay, so degree of the polynomial will be the highest degree, that is 3, value of the leading coefficient is -4, in the end behavior is the degree is odd degree, and negative leading coefficient means decreasing trend. Multiplicity of a root in a polynomial function. Every root has multiplicity, which refers to the number of times that its associated factor appears in the polynomial. For example, the polynomial f of x is equal to x minus 5 whole square is x plus 3 has double root at x is equal to 5 and a single root at x is equal to -3. If a root has odd multiplicity, graph will cross the x-axis at the root. If the root has even multiplicity, graph will bounce off and not cross the x-axis at the root. For example, if it has one single root, so it is crossing the x-axis at the single root. If it is multiplicity of 2, double root, so it's crossing the x-axis like this in the double root. It is 3 roots, so it is 1, 2 and 3. 4 roots, 1, 2, 3 and 4. So revisiting the end behavior of the polynomial functions is as end behavior, the way a function f of x behave for large value of x for very small values of x. To determine the end behavior of a polynomial function, we look to the far left values of the x-axis as x approaches to negative infinity, and the far right values of the x-axis as the x approaches to positive infinity. The sign plus minus of the leading coefficient of the polynomial function will impact its behavior. So as x approaches to infinity, f of x approaches to positive infinity, and x approaches to negative infinity, x approaches to negative infinity. It is called increasing trend. Negative infinity and infinity, it is called decreasing trend. Okay, so graph of the polynomial function. Linear function has one real root. So quadratic function has degree 2. It has 2 single roots. For example, it has y is equal to 2x plus 2, one real root. So for example, it has y is equal to x plus 2, x minus 2. It has 2 single roots. Or it can has one real double root. X minus 2 whole square means one real double root. 2 imaginary roots means there is no point on the x-axis. Quadratic function is an even degree function. Cubic is an odd degree function. It has 3 single roots. Three single roots means this means x plus 3, x minus 1, x minus 2. 3 real roots, one single and one double means this one is double root, this is single root. Three real roots, one triple. one real root plus two imaginary roots means y is equal to x plus 2 x square plus 1. Quartic means again even degree. Four real roots, 1 2 3 4. Four real, two single and one double, like this. Two double, four real roots, one quartic. Example, okay. Two real single roots and two imaginary single roots. These are two real, one real double root, two imaginary single roots. Four imaginary roots. Four imaginary roots. Sketch the graph g of x 1 by 2 x plus 4 x plus 1 x minus 2. So it would be x is equal to minus 4 minus 1 minus 2 minus 4, x is equal to negative 1, x is equal to plus 2. One by 2, sorry, we need to check that it's 1 by 2, so it's increasing trend, positive. For y-intercept, we need to put x is equal to 0. So x is equal to minus 4 minus 1 plus 2, y is equal to minus 4, degree is equal to 3, and leading coefficient is positive, so increasing trend. Consider the polynomial function y is equal to 3x square x plus 5 whole cube x plus 2 x minus 3 whole square. List the roots of the p of x with their multiples. X square means double root at x is equal to 0. X plus 5 means triple root at x is equal to minus 5. Single root at x is equal to negative 2, and double root at x is equal to 3. So x is equal to 0, then minus 5, minus 2 and 3. Double root, triple root, single root. This is again double root. Which is what is the degree of the polynomial? Sketch the graph of p of x and label x and y intercepts. Finding a value. There are infinite number of quartic functions that have a double root at x is equal to -2 and single root at x is equal to 1 and x is equal to 4. Three possibilities are shown. In general, the equation for such a function would be f of x is equal to a x plus 2 whole square x minus 1 x minus 4 where a is not equal to 0. So what makes each of these quartic functions unique? Each has a different a value. What is the a value of the quartic function on the right that passes through the point 3 minus 250? Write the equation in intercept form for the function graphed below if it passes through the point -1 minus 162. Write the equation in intercept form for the function graphed below as it passes through the point. So at this point it is triple root. At this point it's 1 and it's single root. So it can be written as if y is equal to a x plus 4 whole cube x minus 1. So y is minus 162 is equal to a minus 1 plus 4 whole cube. As they're saying to write the answer, final answer in the standard form, for we need to multiply it. Our cubic function p of x has a leading coefficient 1 in the root. It's minus 6, 1 and 3. Sketch the graph of p of x clearly, identifying the roots of y-intercept. So x would be minus 6, 1 and 3. Cubic function q of x has a leading coefficient of minus 1. The function has a single root at x is equal to 2 and double at x is equal to minus 3. Single at 2 and double at minus 3. Leading coefficient of negative 1, so it would be polynomial function has the equation this. Sketch the graph of r or x clearly and identify the roots of the y-intercepts. So y-intercept, put x is equal to 0, y is equal to 0. So it would be x is equal to 0 and y is equal to 0. X is equal to plus 2, 1, 2 and minus 3, minus 3. Polynomial function has the equation t of x is equal to minus x minus 4 whole square and x plus 3 whole square. So negative means decreasing trend and negative means decreasing. Minus 4 means 1, 2, 3, 4. Write the equation in the intercept form for each of the following polynomials. So this is the decreasing trend, so it's going to be negative 1, x plus 5, x plus 3, x minus 2 and x minus 3. Match the cubic function below with the correct graph. Let's find the y-intercept first. So it would be by putting x is equal to 0, 1, -2, -4, which is 8. So once we get the y-intercept, it's very easy to calculate because the y value of 8 a is equal to 16 is in figure A. Here it is 8. 4 here, it is 4 in C, and in D it is negative. Sketch the accurate graph of f of x. Clearly identify the roots and y-intercept. So y would be 0 and x would be 0, so double root from here. X plus 4, 1, 2, 3, 4, and x plus 3. Sketch an accurate graph. So it's the negative means going in the negative trend from like this, -3 +2 -1, plus -3 and -1 has single roots, so it would be single roots. 2 has triple root. A cubic function has roots at -2, -3, and 1 and passes through the point 240. Cubic function has double root at 0, single root at -2, and f of 3 at 90. A quartic function has a triple root at x is equal to -3,